Hello everybody, and welcome to this video where we would like to share our empirical work on novice developers. This work has been done earlier with a great help from Dr. Syed Ahmed Al-Junaid and Dr. Moto from Mara University of Technology and Abdullah Muhammad Zain from the National University of Malaysia. Program comprehension is the process of understanding programs. The main problem that we are approaching is that novice developers find it challenging to understand codes. They find it difficult to identify the purpose of a small fragment of code. They find it difficult to debug, to trace, or to change the functionality of a code. Many programming educators refer that deficiency to the existing methods of programming pedagogy. The existing methods of programming pedagogy focus on programming knowledge, program writing skills, while program comprehension skills are neglected. The solution that we are proposing is to use tasks as a means to improve program comprehension of novices. Let's understand this approach. Over the past decades, many program comprehension models have been proposed. Most of them share the main basic elements, which are knowledge base, assimilation process, and mental model. These elements are influenced by a number of factors: the programmer, the program, the task, or who is trying to comprehend, what we are trying to comprehend, and why we are trying to comprehend the code. While many literature focus on the effect of programmer and program on the development of program comprehension mental model, or model in general, the tasks are used as measures for program comprehension development. We call this approach as the traditional approach, where task is an indicator of understanding a code. If we want to know whether a developer understands a code or not, we give him or her a task, and if he or she successfully perform this task, we can judge that they understand the code. Our approach is to invert this supplementary role of task from just a measure to be an influential factor of program comprehension development. We call this as the inversion approach, where we consider performing tasks can help in developing the program comprehension. We focus on novices and specifically on the mental model of novices. We believe that mental model is essential for novices, and it should be considered before the knowledge base and assimilation process. The knowledge base and assimilation process are external parameters that can be improved over time, and it is not easy to improve them within a short time, as they are based on exposure, expertise, and familiarity. Our definition of novices is second-year students from CS and IT majors, and this definition fit to novice and advanced beginner in the Dreyfus model of skills. So in order to choose the task to be tested in the experiment, we first ask instructors to rank a set of tasks that they believe it will improve the novice's program comprehension mental model. Based on a previous study, we have identified 14 tasks, categorized them based on Bloom taxonomy, and ranked them in terms of their effectiveness on improving program comprehension mental model, but that was based on instructors' perspective. In this study, we are conducting an experiment where we want to test some tasks on novices to check their effect on the development of novices' mental model. So we are comparing the task in each consecutive Bloom categories, and we compare between them in terms of their effectiveness in improving program comprehension mental model. In order to measure the improvement, we are using our program comprehension mental model. That model was proposed earlier in another study. The main idea of that model is to consider code size as an important dimension of the mental model. That is, there are 5 abstraction levels. They start from a line of code, the understanding of a line of code, and then progressing until we understand the entire program. Every statement abstraction level contains a number of information categories. One information category can appear in more than one abstraction level, depends on the code size. So this model was used to develop the pre and post-test questions. So what we do in our experiment is to study the effect of the tasks on the development of program comprehension mental model of novices. Specifically, we are trying to answer 2 questions. Which of the task, the selected task, can improve program comprehension mental model, and what is the specific effect of each task on the different information categories and abstraction levels of novice developers. In the experiment, we focus on 3 abstraction levels so that only a limited number of information categories are considered. These are the details of the experiment. We conducted the experiment on 178 students from 3 public universities, and these are our variables. For each task, we develop a scoring scale. So this is a sample for the modification task. And for the program comprehension mental model, our dependent variable, we develop the pre-test and post-test questions for those information categories, which made up the first 3 abstraction levels. The overall program comprehension mental model is the mean score of the 3 abstraction levels. The design that we are using is 2-group pre-test and post-test design, and it is shown in that slide. So we measure the program comprehension before and after the performance of the tasks. The hypotheses that we identify are 2 hypotheses. The first one is to study the effect of the tasks individually, and the second is to compare between the tasks that are comparable. So we study the effect of the comparable task and we find the differences. These are the instrumentation that we use. This is a sample of the programs we use. We have used 3 methods. This is a sample of the first method. For the pre-test and post-test question, we develop multiple choice questions for each information category. 3 questions for each information category. This is a sample. And for the task questions, we also develop 3 tasks for each of the 6 tasks, 3 questions for each of the 6 tasks. This is a sample. The experiment was conducted as a dedicated workshop in every public university. The actual experiment is here and holding the name of Programming Competency Test. Let's look at the results. Based on the results, we can see that all the tasks have improved the program comprehension mental model, but this improvement is not the same among all the tasks. Some of the tasks are more effective than others. To look at the whether the improvement is significant or not, we did the hypothesis test here to look at the difference between the post-test and the pre-test. So we can see here that the block level has been improved after the performance of all the tasks. While if we look at the information categories, some information categories have been improved just with specific tasks. the general finding that we can derive from is that based on the nature of the task, certain information category will improve. For example, for recall, only the statement the statement goal has been improved, because in this task, the novices need to remember the statements of the code line by line. While for tracing, for example, based on the nature of the task, the students need to follow the task and to follow the code and look at the values of the variables, so that the control flow and data flow of the information categories will improve. So the general finding that we can come up with is that different tasks improve different abstraction levels and different information categories depending on the nature of the task. The second finding that we can derive from the experiment is that, yeah, there exists a difference between the comparable tasks. And the results can be visualized in that figure. The red line shows that that task improved the information categories more than the other task. What we can see is that the task in the higher cognitive category level improved certain information categories more than the lower cognitive category levels. Those on the orange color task are the tasks on the higher cognitive category. So the general finding that we can derive is that higher cognitive categories tasks could improve higher abstraction level in one or more information categories. The last finding that we can derive from the experiment is regarding the appropriateness of our proposed model on describing the mental model of novices. So in order to do that, let's pick one of the tasks and look at the literature. How was it described in improving the mental model? So the tracing in the literature improve goal and data flow, which is part of the situation model. Based on our experiment, this task can improve also the control flow. So there is a consistency in the goals and the data flow, while the control flow was not shown in a Pennington model. So our justification is that maybe because the control flow is general in Pennington model, while in ours it is linked also to the code size. So if it is on the block and module level, maybe it will improve, while if it is in the entire program, maybe it won't be able to improve. So we believe that the conceptualization of the novice's mental model should be detailed and not as abstract as the experts. The implication of the finding is that we are proposing a guide for educators to integrate program comprehension in classes, so that based on the programming level of the students and the information categories they want them to improve in, they can apply the right task. For example, if the programming level of the students are weak and they want them to improve in goal information categories, then they need to let them practice representation task. Another implication is that the proposed program comprehension mental model can be used by educators to measure program comprehension skills. The last point is about threats to validity. We based on segment list of confounding parameters of program comprehension experiments. We try to select the most related one and control them. Our future work is to extend the research to validate the remaining tasks and to focus more on the higher abstraction level. And also we can study the effect of the task on the other elements of program comprehension, the assimilation process and the knowledge base. Thank you so much for listening. Here you've got my email. So please, if you have questions or you want to share your thoughts with me, do contact me. Thank you.